Hello. Hi, everyone. So hello to my in-person crew. Hello to all you watching from home. We are going to do some more coding today. So I'm going to go ahead and check in with the sort of course modules. So today, obviously, we're in Thursday. I'll be putting up new code from today of whatever we do in class. So the code from yesterday, it'll probably just wind up at the bottom of the unit. Sorry, it took me a little while to submit Tuesday's lecture. Sometimes I have stuff scheduled after class, like other classes and student meetings and stuff. So I just didn't get a chance to get to it as quickly as I usually do, but I appreciate everyone who sent me a reminder. It's helpful, even though I didn't forget. Okay, so moving along, today is indeed Thursday. And I'm going to be kind of like tracking along with these slides. As I said last class, I'm not going to be kind of like reading the slides to you because I feel like you can totally do that on your own time. I'm just going to be kind of touching on the main concepts that are in this group of slides. So today we're going to be talking mostly about a little bit about color to kind of just get us into a place where we can make something a little bit more aesthetically compelling. And we're also going to be talking about math, and we're going to start talking about conditional statements. So there's like three things that are kind of on my agenda for today. There is an introduction to a technique called iteration in these slides. We are not going to cover that today. We'll get to that on Tuesday. So just to let you know, like the last couple of slides are going to be sort of expanded on in the next thing of slides. So that's more of like a teaser of what's to come, not exactly what we're up to today. Before we begin, does anyone, or get into the code, does anybody have any sort of any questions about anything, really? Name that tune? Mana Mana. Yeah, it's the Muppets. It's a good one. Okay, so let's jump into the P5 editor. So last time, as far as we left off, I think we had sort of made some basic shapes. Let me just pull up. There we go. So just kind of a general reminder to everyone, before you work in the P5 editor, it's a good idea to make sure that you're logged in. Because otherwise you're not going to be able to save your work. You'll have to copy it, select all, copy and paste it, and things can go wrong there. So it's a good idea to just double check and make sure that you're logged in. I think we definitely spent some time last class. I'm just going to review briefly. We spent some time talking about comments. One more important kind of sort of structural thing that I really wanted to mention, and I just forgot last class, is that in some programming languages, white space matters. In other words, if I were to put 5 line breaks here, that would have some meaning. I do just want to kind of like declare, I do declare that in P5 and in most C-based programming languages, which is what we're looking at, white space does not matter, meaning that there is absolutely no difference between this and even this. Now, would I suggest that you put your code like this? No, I would not suggest it. What is the reason that we would not code like this? This would probably run. In other words, it would probably work, but this is probably really bad. What would be the main reason why this would be less than ideal? Yeah. Exactly. Yes, it's very hard to read. So I'm a huge fan, when I'm coding projects myself, I'm a huge fan of organization. And I'm also a huge fan of kind of being a little bit mindful of how I have things structured. So if you start doing the technique where maybe you decide to put the curly brace on the next line, that's like a common convention. If you decide to do that, that's totally fine. It doesn't make any difference from a functional perspective, but it's probably a good idea to be consistent, because if you have the two curly braces here, and then you have in another function, you have one up here, you're gonna be more likely to kind of miss those mistakes when you make them. So the more consistent you can be and the more kind of visually you can lay out your code, the better your situation will be. So I did want to address that, because I think I did, that was in the slides and I did forget to address it. So today, basically, we're going to pick up where we left off. And I'm actually going to pick up one person asked a really great question just after class, which was basically like, I had two background statements, as I recall. One had the 220, and one had a 0 value. And if I just hit, so the 0 value is actually reading right now because it's being executed after the 220. So if we were to comment this out, we would only see that 220. So somebody asked what this number corresponded to, which is a totally excellent question. And I think that can kind of like maybe get us into one of the things we're going to talk about today, which is color. The short answer is this number is a number between 0 and 255 that corresponds to grayscale value in this case. But how would you know that, like if you just encounter the background function? Well, let's go to the background reference page, and you'll see that there's a lot of different ways that you can deal with the background. So basically what it's telling us, if we scroll all the way down here to the part where it talks about the syntax, background is a little bit unique, where you may remember when we looked at the reference page for ellipse, it only had kind of one sort of option for the arguments that you put in it, right? It was x, y, width, height, and that's it. That's what you get. The background function, like most color functions, is actually context sensitive, which means that if you feed it a certain type of value, like a singular value, it will interpret that as black and white. If you feed it with 3 values right here, those are usually red, green, and blue. And if you feed it with a 4th value, it will interpret that as like an alpha channel, which is a transparency channel. So, so we're going to kind of play around with some of these different ways of specifying color. And I'm going to actually use a little bit of an external tool. So maybe probably like a good sort of common sense question from your perspective is like, well, how do I know what color 255 is? Or how do I know what color 100 is? And I would say to that, well, yeah, that's a great question. 0 is definitely black, and 255 is usually white or the maximum. But there are a lot of color tools. Photoshop, the color picker, actually is one of them. So sometimes I'll just open up Photoshop and keep it open to use the color picker so I can find out what those numerical equivalents are. There's another tool, though, that I thought you all would like that I picked out, and I posted it to today's thing. It's the Adobe Color tool. And so it's just color.adobe.com. And what you get is you get the ability to generate a palette. And that's kind of better because probably for your sketch, you want to have more than one color, right? So you can kind of work through this tool. So if you can go to a bunch of different methods for generating the palette. And then if you just scroll down, it'll give you the numerical equivalents for each color. So we're going to go ahead and just kind of make, this is like a very sort of sunset-y, kind of trendy palette. Sunset palettes are super trendy right now. So we can go ahead and just use this one. I'm totally fine with that. But you can kind of click through here and just generate, like different options. And if you drag it back and forth, you're going to get sort of, closer to white, and here's like closer to fully saturated. So it can be a really, really helpful tool for just generating some kind of like colors out of the blue here. So if we want this sort of like, I don't know, I'm thinking a little bit about this sort of terracotta color. And it looks like that's 212, 91, 100. Over here, you can select multiple different color modes. So today we're going to work in RGB, but if you're feeling a little bit more confident, if you're on the confident side, I would encourage you to explore HSB color. It's actually like my favorite color mode for programming because it separates the hue from other channels. So you can actually use math to kind of like iterate through the rainbow. So I have a couple of examples. I have at least one example in my code library of how to do that. So I may not get to it during class, but if you are kind of an advanced user, I would encourage you to use HSB. We're going to stick with RGB for now, just because it's kind of like the most ubiquitous and it's the most approachable for right now. So basically, I'm just going to kind of like remember these numbers. And over here, I'll just put, of course, I have like the short-term memory of a gnat. So it's 212, 91, 100. Someone can help me remember that for the 2 seconds that I need to remember it. Let's see, 90 and then 100. Woo! Okay, so if I put those values in here, I'm just going to write a note to myself that this is like terracotta. And you can see now I've got that color kind of captured. So color in P5 is kind of a big deal. There's like a lot of different ways that you can address color, but we're probably going to work with two in the time that we're in this class. We'll work with RGB, and we'll also spend a little bit of time working with HSB, which is just hue, saturation, brightness. But for now, we'll just work with that. So let's go ahead and maybe keep our background gray for now, and we can just kind of keep this here for later. I'm going to go ahead and inside the draw function, one thing that I do pretty commonly when I'm getting ready to work with something like a P5 or something in an environment like this is I kind of clear myself some space, and that's for a couple of reasons. The main reason is just so I have like room to work, but the other reason is that by kind of pushing this curly brace down, it reduces the possibility that I'm going to select it and delete it, which is a common problem. So definitely you want to kind of make sure that this last curly brace is still in there, because if you get rid of it, your sketch might not run. So I'm going to come back up here, and let's go ahead and just make a simple box. So in P5 language, that's actually a rectangle. And I believe it's the same syntax as the ellipse, which is basically like an x, y, and then a width and a height. So for x and y, I'll start off with just 0, 0, which is going to put us up in the corner. We're not going to stay there. And then for width and height, again, somewhat context sensitive, I can put just one value, and it will assume that it's a square with 220 as width and height. But I can also actually process it kind of as a rectangle. And then, of course, I'm not going to forget about that little semicolon, that the semicolon needs to be put at the end of every statement. And so just to refresh, all of these things are statements. And this is a function, first line of a function. So all of those statements need to be wrapped inside a function. And so now we should be able to, okay, so there's our rectangle. And yeah, as promised, it's kind of a boring rectangle. It doesn't really have any color, doesn't have anything going on yet. We're going to kind of just like work our way up to that. So probably the first thing that I would do to kind of get myself going on this is to create a couple of variables. So variables in P5 are, if you're sort of somebody who is already a knowledgeable programmer, variables in P5 are called they are not strong typed, which means that if you create a variable called x or a variable called y in this case, what can you put in it? The answer is pretty much anything. You can put in a word, you can put in a letter, you can put in numbers. That sounds like, oh, cool, I can do anything? That sounds great, right? Well, it sounds great, but the important thing for you to remember is that if you start your variable off with numbers, like we are here, we're saying x equals 100, that means that later on in your code, x cannot equal dog. That would be a data type mismatch. And so it's kind of like, seems like common sense, right? That if x is 100, x can't then equal dog. But it's a problem that a lot of people encounter just as you try to do different things. So if you get, yeah, hi. No, you can go. To equal a function call, I don't know if I would use a variable to do it. I would probably use, like, I mean, you can make a function that calls other functions. So yeah, I would do it probably that way, is to basically make like a meta function. So yeah, but in general, I mean, you can store pretty much any kind of data you want in because we're basically in a puffed up version of JavaScript when we're working in P5. I guess the question that you're asking me, I'm interpreting it less as a can you more than a should you, if that makes any sense. Yeah, that's a great question. And we will get into functions hopefully by the end of the 2 weeks here. So yeah, let's kind of, whoop, sorry, that was me. I undid that. So we've got x and y here, and they're equal to something like 100. So here I can draw my rectangle at x, y, and it's going to just shift it slightly to the center of the screen. And so, okay, that's something. And then if I change the value here, it's kind of basic variable stuff. It'll scooch it over on the x. Now it's at 200 instead, and we could even scooch it down by 200, okay? So this variable right now is static, meaning that we assign a value to it at the beginning of the code, and then we're just using it. We're not sort of changing it. The cool part about variables is that if you really wanted to, you could do something like x, to use the increment operator. You can use those variables dynamically to, now we're adding 1 to x with each run. Okay? So let me go ahead and do something here. I'm going to print the value of x. And again, this is why printing to the console is so awesome, because let's say that in our little example here, we start off and x is, doing something, and we have a pretty good idea of what x is doing when we start the code. But when it hits the edge of the screen, like, what happened to x? X totally still exists. If we go ahead and just print it to the console, you can basically see that as it goes off the screen, that variable is literally adding it onto itself into infinity until we stop the program. Okay? So we could also do this a little bit differently in terms of math operators. There's also a minus minus. So we could take it in the other direction. And again, it's just going to add, in this case, subtract 1 every time the program runs. So the reason that it's got this minus minus or plus plus, that's actually called a shortcut operator. It's called in this case, it's the decrement operator. And in the plus plus case, it's called the increment operator. And the reason that it's kind of its own operator is because in programming, adding or subtracting 1 from something is like literally probably the most common math operation that you'll ever do. And it happens on such a regular basis that they kind of made a shortcut for it. So the long way of representing this would be x equals x minus 1. Or plus plus is x equals x plus 1. So it's the same thing, it's just a shortcut by doing the double plus thing. Now, I mean, I think you probably can all realize, hopefully, that starting to use a little bit of math on our stored variables can help us sort of capture motion. We're going to come back around in a few seconds, and we're going to address what we would want to do if we wanted to kind of capture the movement of this box in the actual window. In other words, if instead of having it go off into infinity, if we wanted to have it go maybe to one side and then stop and come back in the other direction, oh, that would be helpful. So in order to do that, we're going to have to use what are called conditional statements. Before we kind of go there, I want to kind of come back to the color real quickly. And we've sort of thought briefly about how to apply color to the background, and that's somewhat useful, I guess. But also useful is the fill object. So I'm going to go ahead and apply this kind of terracotta color to the fill. And don't forget my semicolon. Okay, so we have our terracotta color. Now, I have this one rectangle right here. Just for sort of the sake of thoroughness, I'm going to go ahead and put another rectangle a little bit lower. Sorry, wrong dimension. Actually, I want to take it 200 down. So you can see there's a couple of things happening right now. One is that if I change this maybe even a little bit more, it should be obvious to see. Okay, sorry, I'm just having a huge brain fart. So this is the width and the height, not the position, which is kind of like just me, 100% me, like not seeing the right thing. So here, I actually want to do y plus, like 200. So it's at the same scale right now, but I'm just going to move it 100 pixels, 200 pixels down. You may notice that, maybe a little bit less. You may notice that when I do, there we go, that when I do that, I went ahead and I stuck what's called an expression. Anytime you use like a math operator, you're generating an expression. That I went ahead and stuck an expression into this argument for y. That's a thing you can do. It's a very powerful thing you can do. So definitely, just because it says on the reference sheet x, y, it doesn't really care about how you get there. So you can put literally almost anything in here as long as it will equal a number. So yeah, I could put, like anything. So, but in this case, I'm just adding 150. If you're feeling paranoid, you can put parentheses around it. And what I mean by paranoid is if you're feeling like not confident that the editor will understand what you're trying to do, parentheses are a tool that you can use to basically group things clearly. So that's just another sort of thing to think about. Okay, so now I've got my two sort of rectangles sort of coasting along. Where do we go from here? Well, I think that this fill is nice. I'd like to maybe generate a different fill. So I think I'm going to just steal one of these colors. 220, 113, 235. Okay, so I'm 90% sure this is the color that I just looked at. Of course, if I weren't actually demoing this right now, I would be keeping like maybe a little notes app open or something like that for just cutting and pasting things, but I don't want to clutter up the screen. So I'm going to put another call to fill in here, and I'll show you what happens. So as you can see, it individually colors them, okay? And that's a good thing. Probably going to make this just a tiny bit slimmer. There's a couple of things that you need to know about the fill. So let's say that I have this rectangle. I'm going to comment this out for now, and I'm going to move this rectangle up here. I'm going to move it ahead of the fill. So does anyone want to guess what color my top rectangle is going to be? I sort of broke it, so we're going to fix it. Anybody? Let's find out. Hit the button. Oh, well, that's interesting. So this is just something to kind of note for future reference, that this fill, it applies to what's underneath it, but it also applies to what's ahead of it in the loop. So in other words, it's going to just apply to everything. So let's say for sort of argument that now this fill is kind of applying to everything. What are some ways to interrupt it? Well, there are two ways to kind of interrupt it. One is to assign another color. So that's what I did down here when I had the two calls to fill, right? Another way to interrupt it is to use the function noFill. And so that is basically going to turn the fill off for the rectangle that's at the top of the code, but the bottom of the window. So those are just some kind of things that you kind of need to know. Another fun thing you can do, I'm going to go ahead and just comment these out. And I'll get these going back on. Another fun thing that you can do is you can get rid of the stroke. So the stroke is basically the outline that's kind of all around the objects. Pretty much every object and every shape and 3D object in P5 is going to come with some kind of a stroke. Some people like it, some people hate it. If you want to get rid of it, I would recommend that you set it in setup, and there is a no stroke function, similar to no fill, but it's a little bit different. So now you can see that they're not stroked. So there's lots and lots of options that you can use with stroke and fill, but I feel like those are like the kind of super basic, characteristics of how it applies within the code. I would encourage you just to kind of like experiment and look at other code that you are interested in. So let's talk now about controlling a little bit of this movement. So we had said that in here we wanted to take this terracotta box, and when it hits the edge of the screen, we basically want to make it go in the other direction. So let's go ahead and start on that. So probably what we would do is create some kind of a test, like a logic test. So in this case, the test in sort of, one thing that I really like to do when I'm coding, by the way, is to just kind of literally say in my own language, which happens to be English, what I'm actually trying to do, because unless you can say it, you can't code it, like for real. So if I were doing this myself, I would say, okay, when the box reaches the end of the screen or the window, I want to test for the value of x, something like that. So, because really what I'm caring about is the x-coordinate, right? The x-coordinate is what's pushing it over. So probably I want to use what's called an if statement. And an if statement is a conditional statement. It's a way of saying these things inside my parentheses, if these things are true, like logically true, then I have the ability to do the statements that I'm wrapping in my function self. So let me go ahead and just show you what that would look like. So if some stuff equals true, then okay, so that's pretty much in sort of English what we're actually doing. Like if something, and then you use a double equal sign inside of an if to assign whether it's true or not, then we're going to tell it to do some stuff based on that. So probably what we would want to say is something like if x is less than width. Width happens to be a system variable. Conversely, you could just use the number of the width, which is 400. But I'll go ahead and just use the system variable for width. If x equals width equals, let's see, if x is, yeah, I think actually we could just test for if x is greater than width. Let's try that. So this is basically the statement that we're evaluating. Sometimes you use the equal sign because you want to find out if it's exactly that thing, but in this case we just want to know if it's gone over, right? Because as the x, we know because we've seen it work that it's just going to keep going. So if it's any number over width, then do some stuff. So probably the some stuff that I would like to do is, just to start, I'm going to print x to the console. So I'm going to basically just find out if this is working. And it looks like right now, there we go. So now you can see it's printing that it's at 401, and it's just going and going and going, right? Okay. So probably the next thing to do would be to think about what this is. And so right here, we've got x printing to the console. We've also got x sort of getting a number added to it with every frame. So it seems like maybe it would make sense that here we start to take x and subtract from it. By the way, this is not going to work, but I want to show you kind of why. Okay, so we go over here, 401. What has happened? Something has happened. It's sort of good, but not really. X has basically, what's happening is it's doing exactly what we're telling it to do, which is one of the infuriating things about programming, that as you sort of like get into it, you have to be super specific about what you want. So what we're asking it to do right now is that if x is greater than width, x minus minus. So we're sort of like writing in our own sort of like crappy logic. And basically what's happening is that when it gets over width, it goes to 401, and then it subtracts 1, and then it's now under width, so it adds 1, and it's basically like caught in a loop, right? So what we're going to have to do is we're going to have to do something a little bit more tiny bit more sophisticated rather than just kind of subtracting and adding. Probably what I would like to do in these cases is create a variable called direction. And I'm going to let direction equal 1. Negative 1. It's going to be efficient here. And so probably I'm going to do 2 things. I'm going to not do this. Here, I'm going to say x plus equals direction. And so this statement is a little more flexible, right? It's basically giving me the option to add 1, or if I change the value of direction, I can subtract 1. So it's just a slightly different way of doing it. I'm going to test it right now just to make sure that it iterates across the screen. Well, we're going in the other direction, but that's because I changed it to a plus. OK, so that's fine. So now, basically, what we would want to do, I think, in this if x equals, or if x is less than width, we could say something like direction times equals -1. And all of these plus equals and times equals, x plus equals direction is exactly the same as this, but instead of 1, it's direction. And times equals direction is literally the exact same as direction equals direction times -1 in this case. So again, it's another shortcut operator. If you feel more comfortable, if it makes more sense to you to type things in like this, I totally support that. Like, I have no issue with that whatsoever. When I first started learning how to code, I found the shortcut operators a little bit confusing. So in the PowerPoint slides, there's a table that shows what their sort of long-form equivalent is, if that makes more sense to you. So basically, what we're doing is we're just multiplying direction by -1. And so let's see what happens here. Of course, this is hilarious. Maybe not hilarious. It's going in the other direction here because if I just do this, I think it'll go in the positive this direction. And so now you can see it's coming back. OK, that's progress, right? Good progress. And so, yeah. Now, what happened on the other end? Maybe if we printed the value of x, we could see what happens on the other end. Let's do that. OK, so it's going. It's hitting the end. It's hitting 400. Now it's coming back, because direction is negative now. And you can see it's like, it's just off the other cliff, right? So now it's getting hung up on the other side, which is totally like how it works. Don't freak out. Now how do we address that? Well, over here we have this thing where it says basically if x hits the width, if it hits this end, then we're flipping the direction by -1. We're basically multiplying the direction by -1. It seems like we should probably add in a test for the other side to make it captive within the window, right? So how am I going to do that? Well, in if statements, and again, this is all kind of like super outlined in the slides, there is such a thing as a logical OR, which is a way of taking two sort of evaluative statements inside an if statement and saying, basically, if this or this is true, then do some stuff, okay? So if we have this or thing in here, it's basically saying one of these conditions can be true. So if x is less than 0, in this case, then do some stuff. So this is going to fix our sketch, but I want to show you one other thing that we could do with these compound if statements. So what we saw first was basically what's called a simple if statement, and now you can see we're sort of just buffeting the back and forth motion. So this is basically, in my code collection, this is the linear motion example, if you want like a really clean example of this same code. But just kind of to let you know, like, there are a lot of things you can do with these compound if statements. So this one is basically asking us if either of these, either or, so I'll just stick that in the comments here. There's also something called a logical and, which is equally useful, just not in this current situation. So here I can say something like, if this logical and, now it's, with logical and, both statements have to be true in order for the if statement to do some stuff. So my question for you right now, is anything going to happen when I click the mouse? Well, I mean, let's think about it. So we've got this if statement here. It looks like the direction is adding or subtracting from the x coordinate regardless of what happens in the if statement. And the if statement is just changing the direction from one to the other. So what I'm guessing is that it's actually not going, the if statement will not execute.
I'm not sure I understand.
I don't care. That's hilarious. I hate that thing. So anyway, they never understand anything either. It's like, why are they there? So anyway, basically with the logical and in here, this if statement is not going to work. Because we're asking it for the impossible. We're asking if x is greater than width, so if x is over here, and x is less than 0. Not possible. I mean, it's not going to be in two places at once. So this would generate like basically a big nothing. So for this, we're definitely right to use the logical or. Probably another thing to sort of think about, especially with regard to like the initial assignment. I mean, we're working right now on creating something that has movement. And you may say to yourself, like, okay, it's got movement, but why? And what do I sort of care about the thing moving? Well, look what happens if we get rid of the background. And just let it go. When you get rid of the background, you can sort of draw with shapes. So that can be kind of a neat thing to do. I think I'll draw this, this top rectangle. I think I'll draw it at mouse Y, just for fun. So you can do stuff like that when you disable the background. So basically every frame of the animation is kind of captured on the screen. So it's just another technique for generating images. And it's something that you can kind of play with. There are some other things that I want you to kind of think about. probably, I guess we're running out of time, so let me write this on my list for next class. I think I'm going to make sure to cover next class rotation. So I think we got kind of a lot under our belt today, so I'm feeling pretty good about where we're at. One thing that I'm going to bring the background back just to kind of show this. These code examples from everyday lecture, as you can see, are a little bit messy because I'm kind of writing them in real time. The code examples that are kept on the collection portion of the P5 website are sort of code examples that I've had a chance to make sort of look nice and add comments and all that stuff. So yeah, I would continue to explore. And for sure, let me know if you have any questions. I'm available for consultation. So next class, we'll get into sort of repeating yourself in code. Okay? I'll see you all on Tuesday. Have a fantastic weekend.